and we belong together. Notice that it's dark behind me because I'm doing this problem after work today instead of before work or during my lunch break because I had a big tech meeting today. That's probably the hardest part of being a developer is not developing. It's learning how to be a clear communicator, to understand constraints, to understand requirements, and sometimes speak when you really don't feel like it. We all chose this field because, well, we like money, we like solving problems, and we're probably very, what word am I looking for? Kind of not social, right? Maybe we have who cares? Who cares? We're introverted. That was the word I'm looking for. It doesn't matter. Let's go get right into the motherfucking problem. You know, you feel me? All right, so problem 2418, 2418. When I was 24, I was much smarter than when I was 18. Sort the people. So you're given an array of strings names and an array heights. This consists of distinct positive integers. Both arrays are of length n. For each index I, names I and heights I denote the num and height of the ith person. Okay, so these are parallel arrays, right? So if you have Mary, right? Mary's height is 180, John's height is 165, Emma's height is 170. We can tell because they're ordered, right, by their position. Return names sorted in descending order by the people's height. All right, well, the index is what represents the person, right? Index 0 is for Mary, right? And index 0 is for the height of Mary. And now we want to sort them by height, so we'll have height indexes equals sorted range length of heights, right? Because we want to sort the indexes. And how do we determine the order? Well, we'll have a key lambda idx negative, because negative to reverse it, height of idx. So we're basically looking at each index, and we're saying for each index, because each index represents a person and their associated height, let's get those indexes. And then what we'll do is we'll just return names at index for index in height indexes. No! Well, let's see if that works. It's a beautiful short problem, you know. Heights. Sorry. Okay, and then we just submit that, and we're good. Well, so if you did this in an interview, they might be like, well, you know, sure, that's right, but can you make your own sorting algorithm? And I can. So we'll just do partition sort, I guess. Or should we do merge sort? So if you have to do sorting, all right. So you have a pivot, goes random. So you want to make your pivot random to try to ensure, now it could still happen, right? I don't want to get into a bunch of complexity theory here, but pivot partition sort, or quick sort, sorry. Quick sort is the fastest sorting algorithm, but it definitely has its worst runtime complexity, right? It could be n squared, but as long as you just pick a pivot at random, then it isn't n squared anymore. Okay, so length of pivot, or length of list. And then you look at each one and you say left. So we're going to partition sorry, I'm just trying to figure out how we're going to do this. So we'll pop a random element, but that could be n squared too. Well, no, it takes n. It's going to take n to do this whole thing, so it's fine. All right, so we pop a random element. That's going to be our pivot. We'll have a list and we'll have a function that we apply. And that function will be all right, and then L for L in list if f of L is less than or equal to f of pivot. And we're going to apply partition to that with f plus, well, then this will be the location of the pivot. So this problem isn't easy, and it just comes down to, can you regurgitate a sorting algorithm? All right. Crazy how bad this code is. I'm really tired because as I act like a spaz for a minute, I'm like, I'm really tired, you know. Not tired, I'm just stupid. All right, let's run this. At some point, this has to. Can't do pop operations on ranges, so convert that to a list. Jesus. Yeah, I did mean random. Partition is not defined. Guys, I am so sorry. I'm trying to do a freaking sorting algorithm on the fly, and see, I saw the problem really quickly, so you just better hope that I don't know if it's inclusive. It probably is inclusive. All right, if length of list equals 1, return. Come on. Dude. Oh, shit. Didn't have a base case. Stupid. Still not right, though. Okay. There we go. Just debug my way through partition sort. And my runtime's way worse. Because there's optimizations, right? When you use a built-in thing, it's going to be a lot better. But just to show that you could, on the fly, make the same sorting algorithm that's, the best. Works. All right. That was a bad ending to a video. Easy is easy until they ask you to actually build something up. All right, guys. Peace out.